Welcome to math classes. Today we'll see some critical questions from binomial theorem, and in this video, this video is basically fourth video of the binomial theorem, the part 4. Okay, and this is obviously meant for the who's preparing for JEE, BITSAT, and class 11th and 12th boards. Okay, so let's get into the critical questions. Yeah, this is one of the very interesting questions in JEE 2025, which came actually. Why I choose this one here is all such problems you have to deal with the same fashion actually. Okay, whether there is a uh, product here or not, you will be solving in the same method. Okay, so this is the interesting method. The sum of the series 2 into 1 into 20C4 minus 3 into 2 into 20C5 plus. Okay, so there is a positive and negative alternative. First thing, there is a series going on 2 into 1, 3 into 2, 4 into 3, 5 into 4, and so on. Okay, up to 18 into 9, 17. And then there is a combination 20C4, 20C5, 20C6, which is in the increasing order up to 20C20. Okay, and it is starting from 20C4. Okay, note this. It is not starting from 20C0. Okay, how to solve this problem? Okay, so all such problems you have to remember either 1 plus or minus x whole to the power of n formula. Okay, so how we can do this? Let's say this is my s. This is my sum, which I want to find out. Okay, now what I need basically is 1 plus or minus x whole to the power of n, and find a method to get to this coefficient exactly. Okay, so we know that 1 minus x whole power 20 is 1 minus x whole power 20 is 20C0 minus, right, alternate negative numbers you will get, and the coefficients are 20C0, 20C1, 20C2 up to 20C20, and x term will go x square x cube up to x to the power of 20. Okay, now we know that if I substitute x equal to 1, I get the values easily, right. So now only difference is I have with respect to 20C4 it's starting with. Okay, if I have 20C4 coefficient, there is a product 2 into 1. How can I get? If I differentiate this x power 4, okay, this whole series, if I differentiate, I can get 4 into 3, 2 times if I differentiate. I will not get 2 into 1. So how to get 2 into 1? Okay, so this is the interesting thing. Most of the problems are there with directly you differentiate, you get 4 basically. So it will be like 4 20C4 minus 5 20C5 plus 6 20C6, like that. Okay, but in this case it is not actually 20C4 don't have the product 4 into 3. It has actually 2 into 1. So for that one, simply you have to divide, because you are having 2 into 1 for 20C4, right? How do you get 2 into 1 here? If I divide this whole expression with x square, correct, then I will have here x square. If I differentiate, I get 2. If I differentiate again, I get 1. Correct. So divide this expression with x square first. Okay, this is if I divide with x square, it is 20C0 divided by x square minus 20C1 x by x square plus 20C2 x square by x square minus 20C3 x cube by x square plus 20C4 x power 4 by x square, and so on. Okay, now differentiate this 2 times. Okay, so if I first thing is I simplified it, okay, coefficients. So 20C4 will have x square. This is my first term in this s. Okay, now if I differentiate 2 times, I get 2 into 1. Correct. So this is what I require. Okay, now differentiate it 2 times. What I'll get is this one. This is first time. Okay, 20 into 1 minus x whole power 19 x square minus 1 minus x whole power 20 into 2x divided by x power 4. Okay, here I get, because it is 1 by x square, I get minus 2 into x cube, minus 2 divided by x cube, then plus 20C1 x square. Okay, then plus 0, this is a constant term. Okay, this x term will go off, and then so on. Okay, 20C4 if you take, I get 2x. Okay, 2x. Okay, now if I differentiate again, I get 2 into 1 here. Correct. So differentiate again, I am calling this LHS side as f of function of 1 minus x, because if I substitute x equal to 1, everything will become 0 anyway. So I'm not interested in differentiating this again, because it will be anyway 0. Okay, and here it will be 2 into 3 by x to the power of 4. Okay, and minus 20 into 2 x cube plus 2 into 1 into 20C4 minus 3 into 2 into 20C5. This is exactly, the pink color is exactly my s. Okay, my s. So I'll just replace this with x by substitute x equal to 1. So this will become, this side is 0. So 0 equal to 6 minus 40 plus this whole thing is s. So what I need is s. So s is nothing but 34. That's the answer. Okay, hope you understood this trick actually. Almost all the problems which come in this fashion, okay, you have a series going on, combination series going on, and then product with some number, then this is how you should solve. Okay, either you may have division with some x power p, or there may not be any division also. Okay, directly if you differentiate, you may get these quotients exactly what you're looking here. Okay, so this is one kind of problem which you should know, because this kind of problems you can solve only this way. Okay, 1 minus x, 1 plus or minus x whole to the power of n, way you can solve it. Okay, so next, let 1 plus x square whole to the power of 10 equal to a0 plus a1x plus a2x square up to a20 x to the power of 20. This is, sorry, okay, x to the power of 20. Okay, then if a1 plus a3 plus a5 up to a19, odd indexes basically. Okay, odd indexes. Okay, plus minus 11 a2 equal to 121k, then what is the value of k? Basically we need to find out this value and a2. That's it, right? So how do you find it? We know that if I substitute sum of all these quotients is, if I substitute x equal to 1, I get, correct? So if I substitute x equal to 1, I get a0 plus a1 plus a2 up to a20, which is equal to 3 to the power of 10, because if I 1 plus 1 plus 1, 3 to the power of 10. Then if I substitute x equal to minus 1, I get a0 minus a1 plus a2 minus a3. Basically even and odd indexes will have positive and negative signs, which is equal to 1. Because if I substitute 1 minus 1 plus 1, so 1 to the power of 10, which is 1. Okay. Now, if I subtract these two, all indexes with even, all quotients with even indexes will go off. A0, A2, A4 up to A20 all will go off, correct? And A1, A3 all odd quotient, all odd index quotients will have 2 times, basically double, correct? So my A1 plus A3 plus A5 up to A19 is nothing but, because I'm subtracting 3 to the power of 10 minus 1 divided by 2, because they will get 2 times these values, right? Now I have this one already. This I got. Now all I need is 11a2. Index a2 means quotient of x square. Okay. Now this is a multinomial, so I have only one formula to solve multinomial, correct? Which is nothing but, if it is multinomial in a plus b plus whole to the power of n, I will have sigma l plus m plus n equal to n basically, or in this case it is 10. 10 factorial by l factorial, m factorial, n factorial. Okay. A to the power of l, b to the power of m, and c to the power of n. Okay. So I need x square term. Okay. For x square, my l plus m plus n should be 10, and lmn should be in such a way that I get only x square out of it. Okay. So my possible lmn are only 901. Okay. I can have 9 ones and 1 x square, correct, which is the x square term, or 8 ones and 2 x's. Okay, x into x square, so again, and 0 x square, so I will again get x square term. This is the only way I can get my x square term. So by substituting this one, my x square coefficient is, okay, 10 factorial by 9 factorial into 1 to the power of 9, 1 to the power of 0 into 1 to the power of 1, plus 10 factorial by 8 factorial into 2 factorial, 1 to the power of 8 into 1 to the power of 2 into 1 to the power of 0. This is nothing but 10 plus 45, that is 55. 55 is my A2. Okay, now I have all the values, correct? So this given expression is 3 to the power of 10 minus 1 by 2 minus 11 times A2, right? So 11 times 55. Now this is a simple mathematical calculation. You can do it yourself, okay, which is equal to 121k. Okay, so k is nothing but 239. That's the answer. Okay, hope you understand this problem. Most of the multinomial problems you will solve only using this formula. Okay, and this is the trick how you will get this quotient, sum of quotients exactly. How do you find out this half odd and even quotients? So you can use x equal to 1, x equal to minus 1 for even binomial or multinomial, anywhere. Okay, yeah, hope you understand this problem. Next.
Struggling with Maths Olympiad or Engineering Entrance Prep? Let's make it simple. Welcome to Fun with Mathematics, your YouTube hub for mastering IOQM, JEE, and BITSAT with clarity and confidence. For Olympiad aspirants, we dive deep into number theory, geometry, polynomials, recursive functions, and more, with daily practice problems and complete solutions to previous year IOQM papers. And if you're gearing up for JEE or BITSAT, we've got you covered, with full cert classes for 11 and 12, solved exercises, and past year questions across topics like trigonometry, complex numbers, calculus, probability, and statistics. Every concept is broken down with tricks, trades, and visual clarity, so you don't just memorize, you understand. Whether it's sets and relations or the binomial theorem, we simplify the toughest topics and help you build real problem-solving power. Subscribe now at youtube.com/@psk99999 and let's make math your strength.
Let a equal to 1 plus 2c2 by 3 factorial plus 3c2 by 4 factorial plus 4c2 divided by 5 factorial and so on, infinite series. And b is equal to 1 plus 1c1 plus 1c0 divided by 1 factorial plus 2c0 plus 2c1 plus 2c2 divided by 2 factorial and so on. Okay. Then what is the value of 2b by a square? Okay, now look at this is the infinite series. So mostly you have to check whichever is the closest infinite series expansions which you have. Okay, this is very close to e factor, e to the power of x basically. Okay, so let's check. This is my e to the power of x, correct? If I substitute x equal to 1, okay, I get something very close to this. Not exactly same, very close to 6. Let us find out how to get these 2c2, 3c2 and 4c2 terms on the top. Okay, so e power x is nothing but sigma r equal to 0 to infinity x to the power of r by r factorial. Okay, now my a is nothing but this value which is given, correct? So this is nothing but if I write in sigma format, okay, a is nothing but 1 plus rc2 divided by r plus 1 whole factorial, and r is running from 2 to infinity, correct? Because it is 2c2 3 factorial. Okay, if I expand this one, okay, 1 plus sigma r into r minus 1 rc2 is nothing but r into r minus 1 divided by 2, okay, divided by r plus 1 whole factorial as is I wrote it. Okay, now I can change the numerator into r plus 1 minus 2r. Okay, and here I am separating r into r plus 1 divided by r plus 1 factorial into 2. So 1 by 2 into sigma. Okay, r into r plus 1 will get cancelled. I am left with r minus 1 factorial here. Okay, this is simplification. Okay, minus 2r by this value. 2r I am writing it as 2r. I am writing it as 2 and 2 gets cancelled. So r is I am writing it as r plus 1 minus 1. Okay, so that I can cancel r plus 1 with this one. Simplification again. Correct? Now look at this value and e power x expansion. Okay. Okay, this is if I substitute x equal to 1, this will become sigma 1 by r factorial. Correct? Sigma 1 by r factorial. This is 1 by r minus 1 factorial, which means only one term is less. Correct? So this is nothing but e minus 1. This is nothing but e minus 1. So I'll substitute 1 plus half into e minus 1 minus this. I'm splitting it again. R plus 1 divided by r plus 1 whole factorial, which means 1 by r factorial minus 1 by r plus 1 whole factorial. Okay, now again compare this with your e power x. Okay, here it is starting with 1 by 2 factorial. That means here, so two terms are missing. So e minus 1 and this is also will become 1 if I substitute x equal to 1. So 2, e minus 2 this is. Okay, minus e minus 2. And this value is nothing but it is starting from if I substitute r equal to 2, 3 factorial onwards it will start. Okay, it starts from 3 factorial. So 3 terms are missing. So e minus 2 minus 1 by 2. Correct? E minus 2 minus 1 by 2. This is the value of my a. So if I simplify it, a is nothing but e by 2. Okay. Now what is b? B is very simple because each numerator has complete. If you see this 1c1 plus 1c0, which means complete, right? This is nothing but 2 to the power of 1. Correct? 1 plus 1, 2 to the power of 2, that is 2 to the power of 1. This is 2 to the power of 2, 2 to the power of 3, and so on you will get. So this is nothing but b is 1 plus 2, 2 to the power of 1 by 1 factorial plus 2 square by 2 factorial plus 2 cube by 3 factorial and so on. Which is nothing but if I substitute x equal to 2, basically I get e square. Right? This is nothing but e square series. So e square, b is e square. Now all I need is 2b by e square. So 2b by a square is nothing but 8. This is the answer. Okay. Hope you understand this one. Okay. Whenever you see such infinite series, take it to the closest expansions. Okay. And then solve the problem. Okay. Yeah, this is definitely tough. You need to get a lot of idea actually. Okay. But by practice, you can definitely remember all these things, tricks. Next. The quotient of x power 30 in 1 plus x, 1 by x whole to the power of 6 into 1 plus x square whole to the power of 7 into 1 minus x cube into 1 minus x cube whole to the power of 8. Okay, where x is not equal to 0 is alpha. The quotient of x power 30 is alpha. Then what is the value of absolute alpha? That's the question. Okay, so simple. This is, don't get confused with such a big expression. Okay, first thing is make everything into simple equation. Okay, so quotient of x power 30 from this one I require. So basically I'm taking the LCM of this one. So this will become 1 plus x whole to the power of 6 into 1 plus x square whole to the power of 7 into 1 minus x cube into whole to the power of 8 divided by x to the power of 6. I need quotient of x power 30 from this, or if I remove this, I need x power quotient of x to the power of 36 from numerator. Correct? Now this one is simple. Take general term of each one. General term is if I take 6cl into x to the power of l. Okay. 7cm, then x to the power of 2m. 8cn into minus 1 into whole to the power of n and x to the power of 3n. Correct? So this is my x to the power of l plus 2m plus 3n. Now I have everything in place. Correct? What are the conditions? Just put the conditions here. L plus 2m plus 3n. L plus 2m plus 3n should be 36. Correct? I am looking for x to the power of 36 quotient, so 36. Okay. Now L is less than or equal to 6, M is less than or equal to 7, N is less than or equal to 8. Okay. Now these are the conditions. Just find out all the values, draw a table here, L, M, N. Okay. And make sure that all the conditions are met. Okay, how to do such things? First take the biggest number. N equal to 8 is the biggest number, so start from there. You take 8, n equal to 8. What are the possibilities? L plus 2m plus 3n equal to 36 condition should be satisfied. Okay, so first is n equal to 8, m equal to 6. Then again keep n equal to 8, you will get 5 and 2, 4 and 4, 6 and 3. Now you change n equal to 7, you get other 3, n equal to 6, other 2, and that's all. Okay, you will not get any other values. So these are the values. Carefully write the quotient because you are getting a very big expression here. Okay, so the quotient is 60, like, I mean, if I see this is nothing but 60 into 7c6 into 8c8 plus 6c2 into 7c5 into 8c8. Like this, you keep on writing all the expressions, and wherever there is a negative sign, carefully put the negative sign. Okay, and then if you simplify this one, okay, if I simplify, carefully simplify it, what you will get is minus 678, which is alpha. So I'm looking at absolute alpha, which is 678. That's the answer. Okay, yeah, next. Let alpha be the constant term in the binomial expansion of square root of x minus 6 by x to the power of 3 by 2 whole to the power of n, where n is less than or equal to 15. If the sum of quotients of the remaining terms in the expansion is 649 and the quotient of x to the power of minus n is uh, lambda alpha, then what is the lambda equal to? Okay, so first thing we need to find out is constant term, that is alpha. Then find out x to get the constant, and the remaining quotients is 649, it is given. So find out n value with that basically, and once you know the n value, you know what is x to the power of minus n quotient. Correct? So there are three things to do here. Okay, this is my common term, right? NCR x to the power of n minus r divided by 2 minus 6 whole to the power of r x to the power of minus 3r by 2. Okay, this is nothing but if I take all x terms into 1, NCR x to the power of n minus 4r by 2 into minus 6 to the power of r. Now for constant term, this should be 0. Correct? So n minus 4r equal to 4r divided by 2 is 0, or n equal to 4r. Correct? So my tr plus 1 is nothing but or my constant term is 4r cr into minus 6 whole to the power of r. Okay. Now once I know this one, with x equal to 1, we get sum of all quotients. Correct? X equal to 1, I get sum of all quotients, which is minus 5 whole to the power of 4r, n equal to 4r. Okay. If I substitute x equal to 1, I get minus 5 here, minus 5 whole to the power of n. So n is nothing but 4r. So minus 5 whole to the power of n equal to 649, because this is the sum of quotients of remaining terms plus constant term, which is nc n by 4 into minus 6 whole to the power of n by 4. 4r is nothing but n. So that's how I'm writing. Okay. So now we need to solve this problem, right? This is not a easy, it's not like a quadratic or some simple polynomial. So only way to solve such problems is by observation. Okay, so you start with the smallest number. Most of such things they'll give which can be easily solved actually with the observation and the substitution basically. So n by 4 first value will be here because this should be integer, right? So first value is when n equal to 4. You check for n equal to 4, this equation is satisfied actually. Okay. So for n equal to 4, you can actually get it 5 to the power of 4 plus 4 into 6, which is nothing but 649. This equation will be satisfied with n equal to 4. So once I know that n is 4, r is 1, correct? So my constant term is nothing but quotient of constant term is alpha equal to 4c1 into minus 6 whole to the power of 1, which is minus 24. Okay. Now all I need is because n equal to 4, x to the power of minus 4 quotient. Okay. Again, I will take it from this one, right? This is the general term power, x power. So this is nothing but minus 4. So I get my r as 3. Okay. So if I substitute, quotient of x to the power of minus 4 is 4c3 minus 6 whole to the power of 3. Okay. This is my lambda alpha. Correct. This is my lambda alpha. Okay. Minus 864 is my lambda alpha, and this is my alpha. So I can easily get my lambda. Lambda is nothing but 36. That's the answer. Okay. Next. Let the sixth term in the binomial expansion of square root of 2 log base 2 10 minus 3 to the power of x plus fifth root of 2 to the power of x minus 2 log base 2 3 whole to the power of m is in the increasing powers of 2 to the power of x minus 2 log 2 log base 2 3. Okay, be 21. Okay, this if the sixth term is 21, that's what it's trying to tell. This is sixth term is 21. If the binomial quotients of the second, third, and fourth term in the expansion are respectively the first, third, and fifth terms of AP, then the sum of squares of all possible values of x. Okay, so this looks very complicated, but divide it, divide the problem and simplify it first. Okay, this is very simple. Binomial quotients of second, third, and fourth terms in the expansion are first, third, and fifth terms of AP. Correct? What are the second, third, and fourth binomial quotients? NC1, NC2, NC3. These are the first, third, and fifth terms of AP. So let's take this one as A. NC1 is A, okay, which is nothing but N. A plus 2D is NC2, A plus 4D is NC3. Okay, now if I want to eliminate the, make a equation of this one. Okay, this is nothing but 2 times NC2 minus NC3, correct? 2 times this value minus this is equal to this value, correct? So 2 times NC2 minus NC3 equal to N, A, which is nothing but N. I can actually solve this one. Okay, simplify this and solve it for N. What I will get is N equal to 2 and 3. Okay, but N equal to 2 is not possible. If there are only 3 terms, then it cannot be first, third, and fifth terms of AP, right? And I am already taking second, third, and fourth terms actually. Quotients of second, third, and fourth quotients. So N equal to 2 is not possible. So N equal to 7 is the only option. Now I know my N, okay, which is nothing but M here. Okay. So I have my M, which is 7. Now simplify this one. Here base 2 and here it is base 2. So I can cancel actually and call this as 10 minus 3 to the power of x. Similarly, here I can call this one as 3 to the power of x by x minus 2. Okay. Now if I remove the square root also, this will become 10 minus 3 to the power of x whole to the power of half plus 3 to the power of x minus 2 by 5 whole to the power of m. M is nothing but 7 here. We already solved that. Okay. Now, what is my T6? Now, T6 is given as 21. Correct? What is my T6 from this one? T6 is nothing but 7C5, 10 minus 3 to the power of x whole to the power of 1 by 2 into 7 minus 5, which is 2. 3 to the power of x by x minus 2 by 5 into 5r. Okay, so 5 is here, which is 21. Now it's just a simplification, matter of simplification. Now to solve this one, very simple. You call 3 to the power of x as some constant, some variable, x, or some k. Okay, so once 3 to the power of x is k, assume, then it is very simple equation. 10 minus k into k by 9 equal to 1, or k square minus 10k plus 9 equal to 0. So k, you will get two values, correct? K equal to 3 to the power of x, which is 1 or 9. So x is 0 or 2, correct? Now you got your x value. Okay, so what is asked is sum of squares of all possible values of x. So sum of squares of x is 0 plus 4, which is 4. That's the answer. Okay, hope you understood. You have to break down the problem carefully. That is most important. Okay, in this question. Next. If the constant term in the expansion of x to the power of 5 by 2 divided by 2 minus 4 by x to the power of L whole to the power of 9 is minus 84, and the quotient of x to the power of minus 3L is 2 alpha beta, where beta is less than 0 is an odd number, then what is the absolute of alpha L minus beta is equal to? Okay, so basically we need to find out the constant term. Okay, from that you will get L value, which is 84 given. Okay, now the quotient of x to the power of minus 3L, because we got L value, okay, is nothing but 2 alpha beta. Okay, now once you know this one, from this expression you will get alpha beta values, then substitute here, that's all. Okay, so let's do it. This is my common term. TR plus 1 is 9CR, x to the power of 5 by 2 divided by 2 whole to the power of 9 minus R into minus 4 by x to the power of L whole to the power of R. Now, what are my x terms here? Because to find out the constant terms, x power, I should equate it to 0, correct? So, x power is nothing but x to the power of 5 by 2, 9 minus R minus LR, which is x to the power of 0. Okay, now what is the quotient of this one? That is also important, because the quotient also makes, I mean, we need to understand the quotient also, right? So, quotient of constant term is NCR, okay? NCR 1 by 2, correct? NCR 1 by 2, because if I remove all the x out of it, basically I'm left with 1 by 2 whole to the power of 9 minus R into minus 4 whole to the power of R, which is given as minus 84. Now, there is only one variable here. Okay, this also I can solve actually easily. Okay, so and this one you can just do it by observation actually, very simple. 9CR 2 to the power of 2R minus 9 plus R minus 1 whole to the power of R, which is nothing but 9CR 2 to the power of 3R minus 9 minus 1 whole to the power of R. So R has to be odd, otherwise you will not get negative value. So try with R odd values, okay, 1 and 3. I think R equal to 3, you will get the solution. Okay, so this is simple. R equal to 3 satisfies the above equation. So R is 3 for the constant term, basically. Okay, so from x to the power of 5 by 2 minus 9R minus LR equal to x to the power of 0. So R is 3. If I substitute it, I get L value as 5. Okay, there are two variables here, L and R, right? So R is 3, we found out for the constant term. So if I substitute, I get L as 5. Okay, now L is 5. We have L value. So x to the power of minus 3L coefficient is nothing but x to the power of minus 15 coefficient, correct? So how do you get? Again, take the common term. Okay, then power is here, and substitute R value, substitute the L value. Okay, and this is my power 5 by 2 into 9 minus R minus 5R equal to minus 15, because x to the power of minus 15 I am looking at quotient. So if I solve this, R equal to 5. Okay, R equal to 5, I get x to the power of minus 15 term. Okay, so now my quotient is nothing but minus 9C5 to the power of 6. This is equal to minus 63 into 2 to the power of 7. Okay, because beta is odd number, that's given. I cannot take 2 to the power of 6 and 126 here. Okay, this is in the simplest form. Okay, and also given beta is less than 0, negative value. Okay, so from this observation I can tell alpha is 7, beta is minus 63. 63. Okay, beta is okay, minus 63. Okay, now L is 5, which we found out. So my absolute value of alpha L minus beta is nothing but 98. That's the answer. Okay, hope you understand these critical questions from binomial theorem. It's all you need to have a lot of patience, okay, and break down the problem into smaller problems and then solve it. That is the most important thing in binomial expansion. Very few tough questions are there in the binomial expansion. Most of them are pretty easy. So don't miss binomial theorem chapter. Okay, you will definitely get not only here, in the future also many uh, problems, actually probability and all also involves binomial theorem some part. Okay, so carefully do these problems. Thank you. Keep doing maths.